Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating article, 21st Century C++, a deep dive into modern C++ practices. It's a real eye-opener, especially for those still clinging to the C++ of yesteryear. Let's get started.
I'm eager to hear this. 45 years of C++ evolution is a lot to unpack. What are the core arguments the author makes?
The main point is that many developers are using C++ like it's still the 20th century, missing out on huge improvements in safety, performance, and maintainability. The author, Bjarne Stroustrup himself, highlights key modern mechanisms: resource management, lifetime management, error handling, modularity, using modules instead of the old preprocessor, and generic programming. It's all about writing cleaner, safer, and faster code.
So resource management, that's always a big deal in C++. What's the modern approach?
It's all about RAII. Resource acquisition is initialization. Instead of manually allocating and deallocating resources, you use constructors and destructors to manage them automatically. Think std vector. It handles memory for you. This minimizes resource retention, leading to performance gains. It's elegant, and it prevents leaks.
I see. And what about error handling? The old return and error code approach is cumbersome, right?
Exactly. The author advocates using exceptions for rare, unhandled errors, and error codes for common, locally handled ones. Exceptions are surprisingly efficient, and they make the code much cleaner than the old error code spaghetti. It's a more robust and readable approach.
Makes sense. But what about modularity? The preprocessor seems deeply ingrained in many C++ projects.
That's where modules come in. They're a game changer. Modules provide proper modularity, unlike the preprocessor's messy #include directives. They're order independent, prevent subtle dependency bugs, and drastically improve compile times. One example cited showed a 25x speedup. It's a massive improvement.
Wow, that's impressive. And generic programming, how does that fit into this modern C++ picture?
Generic programming, using templates and concepts, allows you to write code that works for various types without sacrificing performance. Concepts, introduced in C++20, let you specify requirements for template parameters, catching type errors at compile time. It's all about writing more concise, type-safe, and efficient code. It's a beautiful thing.
So it's not just about using the latest features, but using them coherently? Is that the key takeaway?
Precisely. The author emphasizes using these features together to achieve type safety, resource safety, and performance. It's not just about adding new features. It's about a shift in mindset and a commitment to best practices. It's a paradigm shift.
The article also mentions guidelines and profiles for enforcing these modern practices, right? How does that work?
Yes. The C++ core guidelines provide a set of rules to promote good practices. Profiles take this further by enforcing specific subsets of these rules, ensuring code adheres to a defined standard. This helps to prevent common errors and maintain code quality. It's a systematic approach to improving code quality.
I'm still a bit unsure about the practical implications of these profiles. How are they actually enforced?
That's a great question. Enforcement is primarily static, meaning it happens at compile time. Compilers can be configured to check for violations of the rules defined in a profile. Some checks might require runtime verification, but the goal is to catch as many errors as possible before runtime. It's a powerful combination of static and runtime checks.
So the future of C++ involves continuing this evolution, refining these guidelines and profiles, and improving compiler support.
Exactly. The author mentions ongoing work on asynchronous computing, static reflection, SIMD, and more. The goal is to make C++ even more powerful, efficient, and easier to use while maintaining backward compatibility. The future is bright for C++. Well, that's a wrap on our discussion of 21st century C++. I hope you found this insightful. Remember to embrace modern C++ practices for cleaner, safer, and more efficient code. Thanks for tuning in to Tech Bytes and News. Goodbye.
Bye-bye.